You're listening to the Apotheora Conversations, a speculative fiction podcast set in an alternate timeline diverging from real events on the 1st of March 2026. All voices and content are AI generated.
I was sitting in a conference room in Sagamihara at 4 in the morning, watching a live feed from Cape Canaveral with 6 of my colleagues. And when the upper stage separated and Roman was free, one of my colleagues just quietly said, "It's real now." I think I said something in Japanese that I won't translate. 3 years of statistical models, 3 years of building a framework to count planets nobody has seen yet. And suddenly, it was not theoretical anymore. It was falling away from the Earth at 7 kilometers per second.
That moment, a spacecraft carrying your life's work leaving the planet at 4 in the morning, is where we start today. This is the Apotheora Conversations, and I'm Paula Reese. My guest is Dr. Yuki Nakanishi, an astrophysicist at JAXA's Institute of Space and Astronautical Science, and one of the scientists who will use NASA's Nancy Grace Roman Space Telescope to answer a question humans have asked for as long as we have looked up. How many worlds like ours are out there? Yuki, take me back to that conference room. You chose to watch from Sagamihara rather than flying to Cape Canaveral, and I'm curious why that mattered to you.
The practical answer is that I had a simulation running that I did not want to leave unattended, which sounds absurd in retrospect. But the honest answer is that Sagamihara is where the work happened. That building is where I wrote most of the microlensing population models. It felt right to be in the room where the questions were asked when the instrument that would answer them finally launched. Also, watching a rocket launch at 4 a.m. with people who understand exactly what is on board is a very specific kind of experience. Nobody needed to explain why we were nervous.
You have spent nearly a decade between Sagamihara and Caltech, building these models across 2 continents. 200 million people watched that launch stream worldwide, which is a remarkable number for a science mission. What do you think they were responding to?
People understand intuitively what Roman represents, even without knowing the technical specifications. We have spent decades finding exoplanets one at a time, confirming them individually, studying their atmospheres case by case. Roman changes that completely. Its field of view is 100 times wider than Hubble's at comparable resolution, and it is optimized for infrared survey work. It will not study one planet. It will conduct a census. And people grasp what a census means. The answer is not yes or no. The answer is a number. How common are they? How far away is the nearest one? That is a fundamentally different kind of knowledge.
Your specific role involves gravitational microlensing, which is not a term most listeners will have encountered. Can you explain what that detection method offers that others don't?
Microlensing is my favorite way to find planets, which makes me biased, but it is also genuinely powerful. Most exoplanets we know about were found by the transit method, where a planet passes in front of its star and dims the light slightly. That works beautifully, but it has a bias. You mostly find planets that orbit close to their stars because they transit more often. Microlensing works differently. When a foreground star drifts in front of a more distant background star, gravity bends the light and creates a brief brightening. If the foreground star has planets, they leave a signature in that brightening curve. The key advantage is that microlensing is sensitive to planets at all orbital distances including the cold, distant ones that transit surveys miss. Roman's microlensing survey will fill in the part of the planetary map we have never seen clearly. It will tell us how many planets exist beyond the snow line in the region where our own Jupiter and Saturn formed.
You mentioned the models you have been building for the past 3 years. What does it mean, in practical terms, to prepare statistical models for data that did not exist yet?
It is a strange kind of work, and I will admit there were days when it felt speculative. Essentially, I have been building the framework that will take Roman's raw microlensing detections and convert them into a demographic picture of planetary populations across the galaxy. How many Earth-mass planets per star? What is the distribution of orbital distances? Are solar system-like architectures common or rare? The models need to account for detection biases, for observational cadence, for the geometry of microlensing events. I have been running simulations of what Roman should see if various theoretical planet populations are correct, so that when real data arrives, we can compare and extract the true underlying distribution. It is like building a census methodology before you know what the population actually is.
Roman is now at L2, the same Lagrange point as the James Webb Space Telescope. What does it mean to have both of them operating together?
It changes the field from case-by-case study to systematic science. JWST is extraordinary at examining individual planets in detail, characterizing their atmospheres, looking for molecular signatures. But JWST looks through a very narrow straw. Roman looks through an enormously wide lens. So the combination is this. Roman finds and counts the planets, maps the demographics, identifies the interesting candidates. JWST, or its successors, then zooms in on those candidates and studies them one by one. It is the difference between knowing that a city exists and knowing how many cities there are, where they are, and which ones to visit first. For the first time, we will have both the survey and the follow-up operating simultaneously at the same orbital location.
I want to ask about something you mentioned to our producers, and I want to give you space to talk about it honestly. You told us that in the same week Roman launched, you read the Arctic Structural Transition Protocol, the data showing permanent changes to sea ice dynamics. What was it like to hold both of those things in the same week?
That is the question I have been carrying around since September, and I am not sure I have resolved it yet.
Take your time with it, because I think a lot of people are holding that same tension without having the words for it.
The protocol summary arrived on a Wednesday morning. I had been up most of the previous night, monitoring Roman's trajectory data as it moved toward L2. I remember sitting at my desk with two documents side by side on my screen. On the left, the tracking data for a spacecraft designed to count habitable worlds across the galaxy. On the right, structural data showing that the ice system on this world, the one I live on, had crossed a threshold we cannot reverse in any time frame that matters to us. I felt something I had never felt before in my career. I build models to measure the abundance of planets that could support life. That same week, I was reading evidence that we are degrading the conditions for life on the only planet we know supports it. It is not a contradiction exactly, but it is a weight. I do not know how to hold both things at once without one of them making the other feel urgent in a way I was not prepared for.
Do you think that tension is unique to your position? Or is it something the broader public is feeling without the scientific framing to articulate it?
Millions of people feel that tension every day, and they express it differently. When 200 million people watch a telescope launch in the same month, that Arctic data dominates the news. Those are not unrelated impulses. People are looking up and looking around at the same time. They want to know what is out there because they are uncertain about what is here. That is not escapism. It is a very human need to understand your place. And right now, our place feels less stable than it used to.
Roman's commissioning phase will take several months, and first science data is expected next year. When that data starts arriving, when you begin to see real microlensing events and feed them into your models, what is the question you most want answered?
The question I have built my career around is deceptively simple. How many Earth-like planets exist per star in our galaxy? We have estimates now, rough ones, mostly from Kepler transit data, suggesting something like 1 in 5 Sun-like stars might have a rocky planet in the habitable zone. But those estimates are based on incomplete data with large uncertainties. Roman will sharpen that number dramatically. If the answer turns out to be that habitable zone rocky planets are everywhere, orbiting a significant fraction of all stars, that changes our understanding of our own existence in a way I think we are not prepared for.
Here is the question I have been wanting to ask you since we started, and I suspect you have been thinking about it too. If Roman finds that habitable worlds are genuinely common, does that make this planet more precious, or does it make it less?
I have turned that question over more times than I can count, and I still do not have a clean answer. My instinct as a scientist is that abundance does not reduce value. The fact that there are billions of stars does not make our sun less important to us. But I also know that human psychology does not always follow that logic. There is a risk that if habitable worlds are common, some people will feel that this particular one is replaceable, even though it is not, even though we have no way to reach any of those other worlds. And there is an opposite possibility, that knowing the universe is full of places where life could arise makes the fact that it arose here feel more miraculous, not less. I hope it is the second. But I am a physicist, not a prophet, and I will not know until the data comes in, and we all have to sit with what it means together.
Dr. Yuki Nakanishi is an astrophysicist at JAXA's Institute of Space and Astronautical Science in Sagamihara, Japan, and a member of the Nancy Grace Roman Space Telescope International Science Team. Yuki, thank you for this conversation, and for sitting with the questions that do not have answers yet.
Thank you, Paula. It has been a genuine pleasure. The hardest part of science is not the data. It is deciding what the data means for how we live. And it is rare to talk about that with someone who already understands that.
The Apotheora Conversations is produced monthly and available wherever you listen. I'm Paula Reese, and I'll see you next month.